So thanks for coming tonight, everyone. I hear we've got people from all over the world. So good morning, good afternoon, good evening, wherever you are. Thanks to Dan and Matt for hosting. Let's talk dependency injection. So a quick introduction from me before we get going. My name's Steve Collins. I've been programming in one form or another since the early 80s, where I started with the ZX Spectrum. Professionally, I've been doing this since the early 90s, starting with VB3 and then going right the way through to now with .NET 5. As I've got quite a common name, I go by the alias of Steve Talks Code for both my blog and my Twitter handle. As I go through the talk, I've got a couple of breaks for questions. So if you want to put them in chat, and I'll try and answer them there. I may not have the right answer, but I will try and answer them. So with the introductions out the way, let's take a deep dive into dependency injection. And I promise no more pictures of needles and syringes and stuff like that. So before I get going, I've had to make a few assumptions about what you already know about dependency injection in .NET Core. First is that most of you are familiar with using a host builder of one flavor or another to go and create your container. Whilst you can also go and create the container directly from the service collection without a host builder, I'm not going to go into the full details of that in this talk. Next assumption I'm making is that familiar with using startup class to register your services via the configured services method. Then you point your host builder to your startup class via the use startup. And as you can see here, we've got a default host builder to set up a web application using the more specific web host builder. Next is various types of dependency injection supported by many of the IOC containers. But for now, what you need to be aware of is that out of the box, the .NET Core container only supports constructor injection. Now, when I say .NET Core throughout the rest of the talk, I'm including .NET 5 and beyond in that term, though I will be calling out some specifics about .NET 5 and C#9 later on. If you're using ASP.NET Core, you do get to take advantage of one of the other types of dependency injection, and that's method parameter injection. As you can see here, all you need to do is add the from services attribute to the parameters you want injected from the container. This means if you have many actions on your controller that have different dependencies, you can avoid injecting all of them into the constructor every time the controller fires up, even if half of them are not applicable to what you're interested in on your action. That makes your controllers and your action methods much more aligned with the single responsibility principle from Solid. Usually, if you want to go beyond the basic out-of-the-box experience of the Microsoft container, you need to look at using other containers, and I'll cover that shortly. But for now, let's look at some of the other injection types that are available. So I mentioned method parameter injection. First one of these is property injection. This is where a class has parameterless constructors, so the normal constructor injection doesn't quite work with it. So you have to go and set your dependencies on properties. Now, out of the box, it can't do that. Now, things like autofac and what have you can do that. What tends to happen is you go and create, it goes and news up your object, and then you go through, set some properties, and then you have a method, something like initialize or build or create to go and prepare the object ready for use. Next, we have named or key-based injection. This is where you identify your dependency by using some key value. Typically, it's string or an enum, or a constant value of some description. Last on the list, we have automated service registration by convention, which is quite a mouthful. And after a cider, I managed to get that out. What happens with that is the container scans an assembly and pulls out all the classes and interfaces and works out what needs to be registered against what, based on some conventions and some rules that you may specify. The good news is that whilst those aren't supported by the out-of-the-box container, I've got some workarounds and some hacks that show you how you can do it without having to rely on another container. But why are those other styles of injection not supported by the Microsoft container? So there's a phrase coined, I think it was by Mark Seaman, where Microsoft container is what's known as a conforming container. It's a fancy way of saying that it's the lowest common denominator of functionality. But what it also does is it adds a layer of abstraction so that you can hook in other containers via a common interface. You're probably aware that there's a number of other container frameworks out there that can be used with .NET. So on this slide, I've pulled the ones that are listed off the Microsoft Docs website as having been adapted or extended to work with the iService provider interface. The downside to that is that you end up having to co-manage the iService provider ways of registering and your container specific ways of registering stuff. And then you need to know who's working out what to resolve and how it's resolving it. And it all becomes a little bit complex. Historically, if you're using .NET Core 2, you'd usually wire up one of these other containers in the configure services method in the startup class. And at the bottom of it, you'd go and build your service provider using some method provided by them and return it as an instance of iService provider. So in the example here, I'm using AutoFac to register an AutoFac module and then return a new AutoFac container. All great. And then .NET Core 3 came along and they changed that. But before I get into how they changed it and what you have to work around, let's look at the typical service registrations before we get into the nitty-gritty. So in this snippet, we have the code that you're sort of pretty likely to be familiar with. So in this example, we're registering some classes with the service collection and giving them different lifetimes. As we've already covered, in most applications, you'll be using the host builder that initializes the service collection with some default services. Once it's done that, it will then call your startup class's configure services method to add the registrations that you're specifying, as we've got here. After that, it will then call the build service provider method on the service collection to go and create the container instance based on those service registrations. Once built, the container will then be used to resolve the instances and whenever you're required. Now, on that previous slide, I said that we're moving from Core 2 to Core 3, or .NET 5 as it is now. We no longer required to return the service provider. In fact, it's now actively discouraged. If you try and return a service provider from configure services, you'll get this Roslyn analyzer warning. The reason for that is since Core 3, the way the service provider is created by the host builder has changed. What it also means is that whilst in Core 2, there was a small performance boost by implementing the iStartup interface when using the web host builder, this isn't supported by the generic host model. So if you want to use an alternative create container, there's a use service provider factory extension method that you call when setting up the host builder. And that allows you to get the alternative container that resolves instances for you via the Microsoft abstraction. Whilst that will register the custom container, you've still got to go and do your container specific registration. So whilst you can do that inside your configure services using the iService provider, if you're doing anything fancy with AutoFac or Ninject or any of those where they're doing something that isn't supported out of the box, you've got to use the configure container extension method on the host builder. But to be honest, that's a bit clunky. It's a bit easier to go and do it inside the startup class. So inside here, I've got an example with AutoFac. Whichever way you chose to do it, you receive the builder instance that's specific to your third-party container and allows you to use the container's own registration methods. For example, AutoFac will provide a container builder where you can register modules. It's important to note, though, that as the container is built by the host builder, you can't access the created container until you get to the configure method, where you can access it via the application services property. So having covered how the container gets built, let's give some consideration to those service lifetimes that we sort of showed in that earlier slide. Now, I'm sure this is pretty much familiar territory, but I've included it to make sure everyone's up to the same level of understanding before we delve any deeper. Firstly, we've got singletons. They're created once and live for the duration of the container's lifetime. Then we've got transients. They're kind of our fair-weathered friends that sort of come and go as and when needed. And last but not least, we have scope lifetimes. And these sort of stand between the two. But I'm going to delve into that a bit later, so I'm not going to go into too much detail now. The thing to consider with all these different lifetimes is that some play very nicely with each other, and some should really be kept apart. Starting with the shortest of the lifetimes, the transient can accept objects that have been created with any of the three lifetimes. Moving up through the lifetimes, we've then got scope lifetimes. Now, because these are slightly longer lived than the transients, you shouldn't really inject transients into them. Lastly, we've got singletons. This is the longest lived of all because it lives for the whole lifetime of the container. And because it's so long lived, you shouldn't really inject either transients or scoped. Now, I've tried to choose my words carefully around that because there's a general misconception that it's not possible to inject incompatible lifetimes into each other. But that's not strictly true. I can't speak for the other containers, but the Microsoft container won't actually stop you. If you have a singleton and its constructor requires an instance of something that has been registered with a shorter lifetime, the container will happily give you that instance. The problem is that the instance you get will have its lifetime promoted up to that longer lived one. So transients become scopes, scopes become singletons, etc. The problem there is that they become locked in. And especially if you're going from transient to, say, singleton, you're stuck. This is known as a captured dependency, where the transient or scoped instance, like the insect in amber shown here, it's imprisoned inside that outer shell. And you can't break out of it until that outer shell is released. But you may be wanting to hit pause and go, when I've done that, I got an exception. It can happen, but by default, it only happens when your ASP.NET Core environment variable is set to development. It's done by some hidden magic that lies within the host builder. However, you can explicitly turn on that behavior by setting the optional validate scopes parameter to true when creating the service provider. This does have a performance hit though, because it's doing all this checking every time that you're trying to go and get an instance. So the general advice is don't do it in production. I'm not going to cover it tonight because I'm a bit on the fence about how much value it actually adds, but there is a validate on build method that will try and help and identify registration problems. But when I read up about it, it's fairly limited in scope, especially if you start doing some of the fancy stuff that I'm going to show you a bit later on. So moving on, given that singletons live a long time, the whole lifetime of your container, and can be dangerous when mixing with other lifetimes, let's think about why we actually want to use singletons, and what their use cases are. Given singletons can be accessed anywhere within an application, things can get tricky if your application uses multiple threads. Therefore, singletons should ideally be stateless, so you avoid any threading complications. But sometimes you may well have some sort of state that you do need to share. These might be things like pooled resources, in-memory queues, or some other type where you're in control of a limited resource that multiple things are dependent upon. Factory classes I'll come on to a bit later, but typically these are created once, and their methods are then called to go and create shorter-lived instances of dependencies as and when you require them. You may have come across the ambient singleton, and what that does is that hides the complexity of accessing shorter-lived objects from things like a singleton. The example that most people may be familiar with is the HTTP context accessor, where in ASP.NET Core, your HTTP context is scoped because it's related to a request response pipeline, but you want to get to it from a singleton, and therefore you end up, you can't put it in the constructor because it's a captured dependency. So this sort of bridges the gap that allows you to get hold of that context via some trickery using the async local storage. Bit of nasty code underneath, but it does the trick. The last of the cases shown here is a mutable state. That's where you don't want to have to go and recreate some resource object over and over again when you know that for the lifetime of your application, it's not going to change. So you may have some lookup data that you want to read once from some very slow resource like a database, a file, or a network service. And the design of your application, you know that the data isn't going to change while your application's running. If you really must have state, give some thought to letting .NET do some of the heavy lifting for you. If you've got collections, consider maybe using the concurrent collections namespace, where the thread safety stuff has been built in for you. For read-only properties, make the underlying fields read-only, so that if someone comes along later and tries to make them read-write, well, at least they've got some work to do to then change the underlying field and may make them think, well, if that's read-only, should I be making this read-write? And they've actually got to do some work to make it a read-write property. For those properties that you really must have read-write, you may want to consider using a thread lock. Now, this is contentious stuff, but stick with me. So in this slide, we can see that we're ensuring that all property access is managed by the thread lock. That way we can ensure that the value is only changed by one thread at any one time. Now, most of you are probably aware that the problem with this approach is that by serializing the access to a property, you get the major performance hit of everything is coming through this one-way path, one at a time. So if that's a web server, that's going to crucify your performance. Even worse, you will have threads queuing up, and you may end up with thread deadlocks, which could bring your whole application down. So you may want to, if you end up with something where you're having to write that single threading marshalling, you may want to go and look at your design, because it may be a code smell. You may want to look at some other concurrent storage way of handling that stuff. I don't have a panacea for it, but it does potentially reek of a code smell. Lastly, consider the impact of having disposables on a singleton. The problem here is that if you expose the dispose method and a consumer calls it, everyone else then has potentially lost access to the disposed resource, which can cause an object disposed exceptions to be raised elsewhere in the application. So your particular use of it is fine and dandy, but everyone else may be sunk. However, if you have got disposables, you do need to make sure that the dispose method is there so that the container can go and clean up after itself once it's done with the resource. To get around this, you may want to consider abstracting the class with an interface. So it's got all the same methods as your concrete class, except the dispose method. That way, as a service type is the interface and not the concrete class, when someone comes along and gets that interface, the dispose method's not there. So you've put some guardrails in place to make it difficult for a consumer to accidentally call dispose. That doesn't stop them deliberately casting your instance back to the concrete type and them calling dispose, but if they want to shoot themselves in the foot, so be it. For transients, there's not really a lot to say other than be careful about what you're doing in the constructor, as you don't have control over when these instances are created by the container. You may have long dependency chains and something gets created way down the track that you haven't thought of. This could have a major performance hit on your application, as if they're doing something like going off to a database every time they're constructed, and there's lots of them being constructed, that's going to take a hit on your application. Moving on to scope lifetimes, these need to be approached with caution and handled with care. In fact, I've seen various blog posts and Twitter sort of tweets where people have said, you know what, they're such a pain, I'm going to ban them from use on my project. I think that's a little bit drastic because they do have their use, but I do understand the reticence if they've come and bitten you before, and that can happen if they're incorrectly used. Hopefully, I'm going to clear up some of the pain points this evening. Now, we've already covered how scoped instances should be used with the other lifetimes. Don't inject into a singleton, but a transient can come into a scoped. But what exactly is a scoped lifetime? Now, if you did a straw poll, the commonly quoted answer that you get is, well, it's related to ASP.NET Core and it's to do with the HTTP request response lifetimes pipeline. But that's not really the whole story. Whilst that's a common use case, the scope is not tied to ASP. You can create your own scopes, but that still doesn't answer what a scope is. So if you sort of go digging a bit more, the general definition is a scope is really there to ensure that objects are only created once within a single unit of work, which does align with the HTTP request response lifetime because it's sort of one thing that goes down and then comes all the way back again. So say you've got several classes that are considered to be within that single unit of work. Those classes interact with each other and all depend on receiving an instance of iWidget instance, for example, and they all sort of injected into their constructors. Therefore, you want to make sure that if they're all taking part in that single unit work, they all get the same instance. So in that respect, a scope lifetime is a bit like a singleton in that it allows sharing of this one object between many things. However, outside that unit of work boundary, you expect to get a different instance. So you wouldn't want my web request to be confused with, say, Dan's web request. However, as I talked about earlier, it is possible to accidentally promote a scope dependency lifetime up to a singleton if it's injected into the singleton constructor. Away from the web, you may be writing a Xamarin or console app, and you may want to manually create a scope. I think it's fairly rare. I think it's more likely to happen if you've got some kind of hosted service that's doing multiple things. I struggle to think of an instance where you might want to do it in a console app, but I don't know. This is done by calling the create scope method on the iService provider instance. This gives you back an iService scope with the single property of service provider, which is an instance of iService provider again. Try saying that after a cider. But this time you've created a boundary around those services. So you're just serving up that scoped boundary service provider rather than what's known as, the root service provider, which holds your transients and your singletons predominantly. That's all a bit of a mouthful. So let's look at how ASP.NET Core goes about doing that. So in ASP.NET Core, the creation of scope is taken care of you when the request response lifetime has started. The server will create a load of service features, but the one we're interested in is the request services feature. As I described just now, the scope factory is used to create the scope as highlighted here. That scope is then used to create a scope service provider, which is then accessed from HTTP's context request services property. Now, when you're writing your ASP.NET controllers, all of this is hidden away, and quite frankly, you kind of don't care. All you need to care about is that specifying your dependencies in the constructor or action methods, as I was saying with the from services attribute. There is one area of ASP.NET Core where it is worth knowing what's going on in the hood, and you do care about scopes versus singletons and transients, and that's middleware. Now, when we talk about middleware, we think about intercepting and handling HTTP requests and responses. Now, because of this, you might assume that middleware is a scoped registration with the DI container, but that's not strictly true. There's different ways you can write middleware. The one most people are familiar with that's been there from .NET Core 1.0 is convention-based middleware, and that's what we've got shown here on this slide. With this type of middleware, you accept a request delegate in the constructor and then call it from within the invoke async method, though it does support an invoke method as well, but they both return task. I never quite understood why there's two methods that do the same thing, but anyway. Inside that invoke async, it uses that delegate to then call the next middleware in the chain in the pipeline. Now, when you're writing middleware, you tend to either before that delegate call, you tend to do something, or just afterwards. Conversely, you might be writing some terminating middleware where you handle a response and you send the response back. And it's only if you can't handle it, then you might pass it on to the next one in the chain. That's how something like static file middleware works. If you have dependencies other than the HTTP context, the conventional part of it is that you add them to your invoke async method as additional parameters. And through magic, they suddenly appear when it's called by the pipeline. But how does it really work? When you register middleware, it's all done in the configure method of your startup class. At this point, the container is already baked, so you can't add more stuff to your dependency injection container. It's done. So how do you go about adding your middleware? So the use middleware, what it's doing under the hood is it creates a pipeline by inserting delegates to the invoke async method. And that's the thing that actually builds up your pipeline. To do that, to get to your instance async, invoke async, it's got to go and create an instance of your class for it to get a handle to that method to go and create the delegate. It does that through reflection. And then it does a bit of magic, then calling the DI to go and inject stuff in as well. Once that single instance is created, all those dependencies are now resolved from the root container and it's all baked in. You've effectively created a singleton, even though it's not in the container. Where that becomes dangerous is if in your constructor you've asked for transients or singletons, the container will quite happily give them to you, and you're back to your captured dependency problem. So what you also need to bear in mind is that the pipeline is only created long before you get your first request. All it is a chain of delegates saying A equals B equals C equals D equals E. So if you try and access the HTTP context in the constructor rather than in the invoke async, you'll get an invalid operation exception thrown, because at that point, it doesn't know about HTTP context. This is long before the first call has come in. Other scope dependencies that are not part of that pipeline may well resolve depending on whether you're in develop mode or release mode and whether you've turned the validate scopes on or not. But as I say, if they get in there, they become capture dependencies. So how does the request that is scoped get dealt with? Well, the request moves through each layer of middleware in the pipeline via the invoke async method that gets called through the delegate chain, not through some interface or abstract contract. To do this, when the middleware is added to the pipeline, the request delegate is created. The delegate acts as a wrapper over your invoke async method. Now, as you can see, the request delegate passed in as a parameter in the middleware constructor to enable the request to be passed down is the next one in the pipeline. So you're free to add any scoped or transient dependencies of parameters to the invoke async, because that is called at runtime when you've got your HTTP context and you've got a scope, you've got a scope provider available. Now, in the previous example, I demonstrated how dependency injection works with convention-based middleware. What's less well known is that there's an interface called iMiddleware that was introduced with Core 2. And that's for getting middleware to work in the same way as controllers and your standard POCOs that you register with your DI container. Now, the problem with the convention way of writing middleware is that it's a bit clunky and it lays a few bear traps for you of unwittingly declaring transient and scope dependencies in your constructor parameters. What the iMiddleware interface does is it allows you to turn what we just described on conventional up on its head. And therefore, this time the invoke async method has a fixed signature based on the interface, and we go and inject our dependencies into the constructor. So given that the method has a fixed signature, and we have to go back to the constructor to inject our dependencies, what is different this time, though, is that the middleware instance is constructed by the DI container and not some black magic using reflection. So unlike the convention-based middleware, we do need to remember to go and register our middleware with the configure services. Then, when we call the use middleware method to register the middleware, the method checks to see if our middleware implements the iMiddleware interface. If it doesn't, it assumes it's convention-based, and it will start doing all sorts of weird stuff if you've got your dependencies wrong. But if it does implement iMiddleware, then what it does is it goes off to the container and asks for an implementation of the iMiddleware factory from the DI container. That in turn calls the DI container to go and get instances of the parameters for our constructor. Now that all seems like an unnecessary step. Why doesn't it just go straight to the container and build an object? The reason is it comes back to these being able to support other containers. So for example, AutoFact could go and create an iMiddleware factory that goes and looks at its more specialist way of going and creating instances rather than the default iService provider way of doing it. If you're interested in finding out a bit more of conventional versus factory-based middleware and how they work with DI, I wrote a blog post a couple of weeks ago, something like that, where I go into a lot more detail in comparing the two different ways of how you write them and how they work with the underlying use method on the application builder. And that's the thing that actually does the real work about building the pipeline. So that's a good place to stop for questions and for me to have a sip of water. I can't seem to get chat up. Dan or Matt, are there any questions that you want to read out?
No questions so far. Just
Okay.
Adam's commented saying that constructors on middleware is a good place to only inject settings options which are used to configure the middleware from I configuration. As its configuration, it will likely be a singleton, so it can't be captured through the constructor.
It depends on how you've registered your configuration, because if you use the configure T method that registers an I options, or you get I options snapshot, and I options monitor, you need to be careful with I options snapshot because that is a scoped dependency. So I tend to try and if it's a setting that I know is only set from application startup, I'll use the I options, and you're right, the I options is a singleton. But if it's something that I want to monitor on each request coming into the middleware, because configuration can do things like file monitors, then I would opt more towards the I options monitor, which is a singleton, but it acts more like a transient in that it'll go and it'll serve up the cached version of your configuration unless it changes, in which case it will serve up the latest version. Okay. Any others?
If anyone does have any questions, feel free to unmute yourself, by the way, if you don't, or type in the chat. It's up to you. A long one from... Oh, Lee, you've sent it to me directly, not to everyone. Oh, there you go, changed it. That's a long one, so it might be worth reading it out, or I can read it out if you want.
Hold on, how do I get chat back up on?
So if you move the mouse, and there's like a drop down that appears from the top. There's like if you move it to the top of the screen. Oh, how do I unmute, he says?
I'm looking at the wrong screen.
Hey guys.
Chat.
So
there we go.
Can you guys hear me?
Yeah, sure.
Awesome. You touched on something very briefly, but it grabbed my interest around behavior changing based on a number of things. Like maybe it was like something to do with debugging or running in different modes.
Yes. The validate scopes about debugging if a service registration fails. So say you've got two registrations, class A and class B, and B is dependent on A, and then you've got another class C that's dependent on B and A, and then another one, D, that's dependent on something else. If you haven't registered the dependencies for D, because it depends on, I don't know, E, F, and G, that validate scopes will try and blow up in development mode. But there's also about scoping, and it'll try and so that's the default behavior of it'll blow up if a dependency is not registered, and that'll happen in runtime or development. Scoping is if C is dependent on B, C's a singleton, and B is a transient or scoped, then it'll try and step in and blow up and say you can't inject this scoped into a singleton. But at runtime, by default, validate scopes is turned off, so it will go through, and that's where you get your captured dependency. Not sure I explained that very well, but
I think I understand it. So it's all around the kind of like an extra runtime checks that validate.
Yeah. So because it does it takes a bit of a performance hit because it's having to go and do these checks. The general recommendation is you don't do that in production, and that's why in the host builder it only sets it by default when ASP.NET environment is set to develop.
Gotcha. Okay, thank you.
Okay. Sorry, I went off on a tangent describing the wrong thing to start with, and then I came back and realised where I was going wrong.
Just one question. Why is the design of ASP.NET such that you have to register the middleware? If you've got an I middleware implementation, why do you have to register it to declare the middleware and the middleware, and then add the middleware? Why doesn't it just do it all in middleware?
Yeah, because it's down in the depths of the use middleware extension method. What it's trying to do is, back in .NET Core 1, it was all convention based. So you didn't have to go and register anything. It went and did it all through reflection, and it was using activator utilities to go and grab other dependencies into it. So that's why you didn't have anything registered in configure services, but you had your use middleware and just said, go and add this into the pipeline. When it comes to iMiddleware, you're not using reflection to go and build it. You're relying on the iMiddleware factory to go off to the DI container and configure it for, create it for you. So because you're relying on the DI container to do it, that's why you've got to go and register your middleware back in configure services. But the important thing to do there is to register it as the concrete type, not as the interface, or because otherwise it won't marry it up, because the service will mismatch the concrete that you're after.
Yeah, I see. Yeah. Cool, thank you.
Okay. Any more or no?
There is a question in chat
from
Nicholas saying, how does @inject iService scope factory on a class work? I think he's like put code in there. So @inject, I think ASP.NET stuff.
Okay, I think, and don't quote me on this because I haven't looked into it in depth, I think it's doing something along the lines of the something similar to what the from services attribute does on a method on a method parameter injection. But I haven't really gone to in depth of the low level how it actually works on that. So I can't give you a definitive answer. I can only give you a guess at what I think it's doing under the hood. Okay. Right. Okay. So I'm going to stop probably about another 20 minutes, and then we'll do another break for questions based on the next section. So earlier I mentioned that you need to be careful with disposables, but now I want to dig a bit deeper into some of the edge cases. So if you remember when I was talking about singletons, I said that you should try and hide the dispose method from consumers, as the container will take care of it. That last bit of the statement is true in most cases, but as you can see here from the Microsoft website, there's a couple of extension methods where you go and create the instances yourself and the container won't dispose of these for you. If you do go and create an instance of a disposable class in this way, there's a bit of a problem, namely that there's no obvious re-entry point to come back into configure services or back into your startup class to get a reference to that instance to go and dispose it. So it sort of kind of lingers there until the whole application disappears, which in some cases may not be the end of the world, but it feels a bit messy. So why would you take that approach? Well, sometimes you need to go and create an instance of an object, and the stuff it needs in the constructor parameters just aren't there in the container. So you've got to give it a bit of a helping hand. In that case, you might want to consider maybe using a factory, which I'll talk about in a little bit. But if you really must do this, there is a get out of jail card available. Behind the scenes, there's an interface that's automatically registered by the host called iHost Application Lifetime. What you can do is you can inject that into your configure method by adding it to the parameter list. So it's a bit like the middleware. In the configure, you can go and add all sorts of parameters to your heart's content because it's all done through a bit of reflection. Here, what you can do is you can add that on application lifetime. Let me get it right. You can register a handler for the application shutdown property, which is an event handler. It's all a bit complicated, and that gets passed through. But ultimately, what you want to do is inside that application shutdown is you get an object injected. As long as you know that type is the thing that you're expecting it to be, you can then go and cast it to an iDisposable and then call dispose. Really, really nasty, and I would run a million miles away from that. But it is there if you really must do it. Coming back to hide and dispose method, if you can't change the class source because you just don't have the source code, and it doesn't already have an abstraction baked in that hides the dispose method, you may want to consider, going back to the gang of four patterns, such as facade, adapter, bridge, proxy. All these are variations of the same kind of theme of you're creating some kind of wrapper class. Right, sorry. You're creating some kind of wrapper class around the creation and disposal of that class instance. The last point I want to make is a rare one and a code smell. Sometimes you might have a class that gets various disposable things injected into it that it knows are disposable, and it will try and go and dispose those things. Now, like I said earlier, that's really dangerous if you've got singletons coming in. So if you've got something like that, what you may want to do is go and write a factory to go and create a one-off instance that it uses and that it can dispose of without affecting something else. Bit clunky and nasty, but it is there if you need it. So next we've got some gotchas that could come up and bite you on the bum when registering or consuming services from the container. Consider what happens when you've got the same service type that gets registered multiple times against multiple different implementations. Now, you may well be doing that deliberately, and I'll walk through that in a minute, but it can happen by accident. For example, you may have a source code merge that's gone wrong, and you've got sort of adding your class in twice, and no one spotted it, that it's gone wrong on a code merge because it's up here and it's down here as well. So you've got two registrations. Or there may be an extension method that's registering a different implementation to the one you're expecting. So you think you're registering iWidget as widget A, and some extension method comes along and registers iWidget as widget B. So you're going to have two different things happening, and it can have unintended consequences. It's down to what happens with the way the container works, and it works by default on a last in wins principle. So if you call an extension method after your registration, that extension method's registration is going to win, sorry. Conversely, if you come in after the extension method, yours will come in. So you need to give some thought when you're in your configure services about if you're calling extension methods that might be touching certain registrations after yours, what the effect is. Now, if they're your own classes and they're your own extension methods, well, it's your foot and you've just shot yourself in it. But it can happen with sort of the more common ASP.NET interfaces and classes, that some of these things like add MVC go and add in sort of 50 to 100 different registrations for you. And if you've done something with one of the built-in interfaces, chances are that's going to get overridden by the extension method. Now, of course, if you're writing extension methods and you're going to publish them to a wider audience on NuGet, the onus is on you to play nicely. And as we know, we need to be careful around object lifetimes as well. And things get really messy if there's multiple registrations with different lifetimes. So you've gone and registered a singleton and someone trumps it with a transient, for example. And that may be that, as I mentioned, you deliberately want multiple implementations. But if we do want to avoid that happening accidentally, there's some additional registration methods that you can use. The first is the triad methods, and there's various variations with generics and so on. But in essence, what it's doing is it flips the last in wins principle to the first in wins principle. So it's a bit like triad on dictionaries, for example. If there's something already there with that key, go away, I'm not going to register you. But that's just purely about the service. So in this example, we've got a triad singleton iPlanet, and the first entry will win. Then on the second one, we're now using triad enumerable. And what that does is it looks at not only the service, but the implementation as well. So in this example here, I've gone and added Earth, Mars, and Jupiter, each of them twice. But because I've tied it up, we'll get Earth, Mars, and Jupiter as multiple registrations rather than just one single registration. So as you can see, I've got the ticks and crosses. Triad singleton, the first one wins, and the triad enumerable, the three first ones win. So that's a few of the gotchas. Let's try and move into some more constructive and helpful hints. If we flip what I just talked about on its head, and you deliberately want to register multiple implementations, the callers need to be aware of that. So why would you want to register multiple implementations? So typical things might be you're registering validation rules by dependency injection. So you've got 6 or 7 validation rules that all implement an I validate. You may have something where you're enriching something, and you've got a series of enrichment classes. So you may be familiar with the Gang of Fours visitors pattern. So you've got a car class, and then one thing will come along and add color to it, and then it will come along and add whether it's got stereo to it, and enriches it as you iterate through all those different classes. So if you do want to do that, and you are deliberately registering multiple implementations, the caller needs to be aware that there's multiple implementations there. If it just asks for iCar or iCar enhancement, for example, or iValidation rule, depending on whether you've used triad or not, it'll either get the first one that was registered with triad, or the last one if you've just used add singleton, add transient, something like that. What's also important is if you've got multiple registrations, the order of the way you've registered them is important, because out the box, when someone asks for an IEnumerable of that service, the order they'll get them is the order that they were registered. Without the consumer having to rely on that order, if it needs to understand the order, there's several ways you could approach it. The first is on your implementations, you could put an iComparable interface on there so that they can compare each other's to themselves and come up with an ordering. That will help you that if you've injected an IEnumerable and you're using link order by, the iComparable will then reshuffle them once they've been injected. You could move that back down into the DI container you could go and create a class that implements IEnumerable and do that sorting within that class. But then your caller needs to know to ask for that class rather than IEnumerable. Lastly, you could really just bake it into the container. And because you've got Lambda expressions for resolutions, you could register an IEnumerable of your class or interface and do it all with some link or some custom logic inside the Lambda inside your registration. Bit clunky though, to be honest. So that's what happens if you've got a single interface with lots of different implementations. But you could be going the other way around. You could have a single class that's got multiple interfaces on it, especially if you've gone down the interface segregation principle from Solid. If you register the type with each interface individually, what you're going to happen is by default, is each of those interfaces will get a different instance. So regardless of whether it's transient or scoped or singleton, if I've got my implementation A and I go register my implementation A as interface 1, my implementation A is interface 2, 3, you'll get a different instance depending on whether you're called interface 1, 2, or 3. Really, what you want that to do, especially if it's a singleton, is you want, regardless of what interface you come in on, you want that same instance to come back. So what I've got in this code here is I start off by registering my class, and I'll talk about the aggregate interface in a minute. But then the key bit is when you register the interfaces, you use the service provider's get required service to go and get that original thing that you've registered. Now, in some cases, you may want to aggregate the interfaces together, as I've done here. So I've got a sort of composite interface of my interface 1, 2, and 3. This may be a benefit if you don't want consumers to be able to request the concrete implementation directly. So if you think back to the iDisposable issue where you didn't want to register the concrete because there's a risk that dispose might get called. Next, we've got open generics, where you define a type parameter on a class type, Now, the place you may be familiar with this is from a DI perspective, at least, is the iLoggerT interface, where inside your control, inside your controller in the constructor, you will say, I want iLogger angle brackets name of your controller. Similarly, I touched on iOptions in answer to Adam's question. That's another thing where you have iOptions T, iOptions snapshot T, etc. If you want to register your own open generic type, the C# syntax doesn't lend itself to referencing open generics with a generic declaration. So instead of having to use what you have to do is you have to use the non-generic registration method, where we use the type of keyword to get the service and implementation types without having the closing type parameter. So you'll see there I've got an I do something generic with the angle brackets, but no closing type inside it. Behind the scenes, what happens is when a container says, I do something generic of string, or string's a bad example, of car, for example. Behind the scenes, what it does is it uses the make generic type method on the type class to go and create a closed generic type. So for example, do something generic of car, of vehicle, or something. It then uses that type with a bit of reflection magic to go and create the closed generic instance that then gets called back to your constructor on your controller. Now, if you've not moved to .NET 5, you may hit a problem if your type definition includes a generic constraint. So you may have something on there that says that T has to be a class, or T has to be a struct, T has to implement this interface. The problem was that during that make generic type action, where it goes and creates the closed type, it was throwing an argument exception, which was blowing the whole stack up. Luckily, that's where Jimmy Bogard of Automapper and Mediator Favors come to the rescue. He did a pull request, and all it was, in essence, was adding a try-catch block around that make generic type and swallowed the argument exception. This now allows constrained generics to be resolved in .NET 5. That's great, except it took 4 years for his pull request to be accepted. So if you go and read Jimmy's blog, you get to understand why there's been very little change in the Microsoft container since the first version of .NET Core way back in where it was 2016. In short, you must ensure that we took all those other containers like AutoFac and Inject or what have you to implement the iService provider. Your change isn't going to go and break those. So what it means is you've got to write loads and loads of unit tests that not only test that you fixed something or you've brought some new functionality to your container, you've got to check that it doesn't break all those other containers. And that's why the container, I went back over the GitHub repo, and there's been very little change over the last 4 or 5 years. So next I want to talk about a couple more of the so-called Gang of 4 design patterns, and I've alluded to them already. The first is the factory pattern. Now you may be thinking, well, hang on, surely the whole point of the container is to be the factory of creating class instances for me. Well, sometimes you have to give the DI container a bit of a helping hand. For example, you may have a class where there's some of the constructor parameters just aren't known until runtime because they may be captured from user input, for example. The container just won't know those. In those cases, you just can't get the container to do it unless you do something really hideous hack with async local, and stay away from that, really stay away. There may be other situations. You go and create an instance that's a really bad resource hog. And we touched on iDisposable earlier of you want the cooler to be able to get rid of it as soon as possible rather than waiting for the container to go and dispose of it for you. Lastly, at the start of the talk, I touched on the Microsoft container not supporting property injection. But by using a factory, we can simulate property injection, because what it can do is it can go and do the newing up of the base thing and then go and add in more properties via your method. What it can do, and why you may want to do it with your DI, is you may have some of the parameters that you want to come through a container. So rather than the thing calling the factory and saying, I'm going to grab these 5 things out of the container and pass them into the create method, your factory can go and grab those things that it does know about in the container and hold them. And then when you come along and just say, I'll give you these extra 3 or 4 parameters that you don't know about, but you do know about the stuff that from the container. And then that can go and build your class instance for you. So those are just a few instances where the factory comes into its own. But let's have a look at a very quick and contrived example where we have a class that registers a singleton. Let me just check that I'm on the right slide. Yeah. So, sorry. First, we've got a class that registers a singleton. Next, we're going to go and create a class that consumes that singleton, but also requires a name parameter in the constructor. Now, given that the name parameter can't be known by the container, as it will be provided by our runtime API controller, we can't add it to the configure services. Now, you may have noticed I've got an immutable class here, but with C#9, I could have used a record type. Now we'll go and create a factory class. First, we'll take the singleton and we'll cache it in a field. And that's shown in the blue highlighted constructor. Then we have the creation method that will go and new up our short-lived thing and use the cache singleton and pass it, and then pass in the name from our method. Next, we add the factory to the configure services as a singleton. And finally, we'll have our controller that takes our factory in the constructor. Later in the get action, it'll then call the make method, but you could have called it build or instantiate or whatever you like, to go and create that new instance of the short-lived thing. Very contrived, but I wanted to give a flavor of how you can mix and match your runtime parameters with stuff that's in the container. Apologies for this if you're looking on a small screen, but there's a lot to pack in on that slide, so I had to do it at quite a small font size. So to summarize factories, unless you register the factory as a singleton, sorry, usually you'd register the factory as a singleton in most of the time because it's stateless. The variations are the parameters in the create method. As it's a singleton, the only other dependents that should be injected into it are other singletons. If you do need transients or scope dependencies, you could take the iService provider itself as a constructor parameter, but proceed with caution. Direct use of the iService provider is considered a version of the service locator anti-pattern. Now, the reason it's an anti-pattern is because you're tightly coupling some of your application code to having knowledge about the container rather than letting the container do all the hard work. Your classes in your application should be oblivious to the container technology. However, with the factory pattern classes, they fall into a group that I sort of think of as servicing classes and plugging the gap at the container. They're not really part of my application per se. So I'm fairly relaxed about it. I know some people get really hung up on the service provider, service locator and anti-pattern, but I think there's a point where you have to be pragmatic rather than dogmatic. And what you can do is you can hide some of that complexity by keeping it within the same. You can potentially make them classes within the startup class so that they never get seen outside in the outside world because they're private within the startup class, but the container can still new them up for you. Alternatively, you could just stick an interface on it so that no one's aware of what's going on inside of it. That way, whichever way you choose, the container can construct them, but callers can only access the methods that have been registered on the interface. A variation of the factory pattern is the builder pattern, where rather than prescribing which dependencies are needed up front, so a factory needs to know some things are needed up front and some things you'll pass to it in the method. The builder is much more flexible. It'll sort of say, I'll give you a pattern where you can go and use properties and methods to go and gradually layer things, build things up bit by bit. So the way I think of the comparison is factory is like the cola dispenser on the left, where it's an old style one where it's got sort of 4 or 5 fixed options, and that's all you're going to get. Whereas the builder pattern is much more like the ones you now sort of see over the last couple of years, where it's got the base thing of it's got a cola, but then you can go and add a dash of lime, bit of strawberry, bit of vanilla. How you can go and compose it however you want it. Now, whilst that dispenser is doing it bit by actually just dropping the liquid in bit by bit, the builder pattern, it keeps that all inside itself until you call the build method. And at that point, that's when it will go and put it all together and give you your instance. So with the builder, we start off much like the factory by registering it with the container. However, this time we register it as a transient rather than a singleton. Now, the reason for that is because once it's been created, we're going to effectively be mutating state of the builder as we go along until we hit the build method. In its constructor, we can take in other dependencies from the container if we so desire. Consuming classes will take the builder as a constructor parameter and then start using the methods and properties to build stuff up as it goes along. Then once it's all configured and the builder's ready, we'll hit the build method and voila, we've got our instance. Now, typically, when you've used the build method, the thing that it generates will tend to be immutable. Not necessary, but it may be. The last thing to mention is that, like the factory, if the instance that you create out the builder is disposable, it's the thing that called the build method that's responsible for disposing of the instance that it created, because it's nowhere near our container. The container's not aware that it's been created, so it's not going to go and dispose of it for you. Now, so far, we've assumed that the factory or builder classes will be using the new keyword to instantiate the class instance. But wouldn't it be good if we could take advantage of the container to do some of the work for us? So in the earlier slides, I said that the problem was working out how to populate parameters that the container doesn't know anything about. Luckily, that's where the activator utilities class comes in handy. There's 4 methods that are effectively 2 methods with generic overloads. The get service or create service will try and create a container to create the instance for you. But if the type is not registered, it'll go and do it via reflection. The other method, and the one that's of interest to us, is the create instance method. What this does is it takes an instance of the iService provider to get an inroad into the container, and then it takes an array of objects. It then does the work of matching the constructors on the requested type to what's been supplied in the array, and then fills in any parameters not supplied from the container. Now, the downside to this is that you're taking a bit of a performance hit because you're using a bit of reflection to work things out, and it's got to work out the order of the different parameters. But where this is useful for our factory or builder is that instead of having to explicitly declare types on the constructor of our factory or builder, we can just say, you know what, I'll just take in the iService provider and let the activator utilities do the hard work for me. So that's been about another 20 minutes before I move into the final section. Any questions?
There's none in the chat.
Stunned silence. Okay, let me have a quick sip of water.
Lee's got his hand up.
Yeah, I'm not sure if I've caught the wrong end of the stick.
Okay.
When I've worked with the factory pattern before,
Yeah.
I've grappled with the problem of wanting to use the service provider as a service locator, essentially.
Yeah.
And the pattern that I've found works is to essentially inject all the instances you would want your factory to create, and then those instances have does apply to method on it, and then the factory uses that.
Okay. Yeah. There's many ways of skinning the cat, and I think it's a case of applying whichever fits best to the way you know what things you've got registered, what things you haven't got registered, and any sort of process work you've got to do in between. But yeah, so with that applied to, is that you're treating it a bit like the visitor pattern? Yeah.
It's like the factory pattern, but without the switch that you often get with the factory pattern.
Right. Okay.
So where the instance itself decides whether it's going to be picked.
Right. Okay. So that's more of an abstract factory pattern. Yeah.
Could well be. Yeah.
Yeah. Yeah. So basically, the abstract factory pattern is it will decide itself and say, if this condition is true, then I'll give you one of these. If this condition is true, I'll give you one of those, and so on. Yeah. Is that where you're coming from?
I think so. So the implementation of the factory would be, let's say you have a parameter which is a name field.
Yeah.
So that's defined at runtime. Then you have
Yep.
all your different instances which could be returned, and then your Volvo instance will go, have you asked for the string Volvo? Yes or
Yeah.
no? Okay, return me, and then so on and so forth.
Yeah. Yeah. So yeah, that does sound a bit. I keep hitting this microphone. Let me move it a little bit. So that does sound a bit more like the abstract factory, but I've got something coming up in this final section you may be interested in, where it shifts that right up into the container. So stay tuned. Any more questions? No. Okay. Right. Okay. We'll crack on with this final section. One final sip of water. Excuse me. Right. Okay. Sorry. Let me just go. Right. Okay. So in this final section, I want to talk about plugging in some of the gaps in functionality that the Microsoft container is missing. I mentioned earlier that property injection is not supported out of the box by the Microsoft container. And as we've just discussed, that gap can be plugged by the factory or builder patterns. They'll go and create the instance for you, go and set the properties and return the created instance with a create or build method. Another place where this can be useful is if you need to create instances of struct value types, where some of the properties come from the container and some of them are coming from runtime. Now, the problem here is that you simply can't register a value type with the Microsoft DI container as it's not supported. So you need to get all the dependencies and instantiate the value type yourself, which kind of defeats the purpose of it. So here you can see I'm attempting to add a struct type registration using the generic add transient. And there's the Roslyn analyzer error to say that's a no can do. You're just not allowed to do that. So you could think, aha, it's because I'm using generic registration. I'll try the non-generic one. And all you've done is you don't get the compile time error. You just kick the problem down the road to runtime. So how do we get around this? We simply create a factory or builder that takes the parameters needed to populate the value types. Now, the example here is very contrived and offers no benefit over just creating the object in your own code. But hopefully you'll get a flavor of where I'm going with this. If some of the properties need to be taken from the container, like we've just been saying about, you can inject the iService provider, you could use the activator utilities, and then you can munge them together with your runtime parameters to go and create your value type. Now, the value type is effectively possibly immutable, but it's one way of doing it. Now, there is a question about why you want to go and create a value type from your container, because usually value types tend to be more about entities, but there may be some situations where you do need to go and create a struct from using the factory. And that does lead us to the new C#9 record types. Now, I'm a really big fan of these, and I've been using them a lot lately. For those that aren't familiar with these, they're a reference type, so they're like classes, and under the hood, if you go down to sort of IL level, they are classes effectively. But they behave like value types, so you get the equality checking, you get a simplified syntax for immutability. There's a whole load of really nice things around records that I like. If you want to find out more about them, the thing that I found was one of the best resources was this on.net show a video, and there's a link there. And if you go to that GitHub gist that we posted at the start, all the links are there. From a DI perspective, as they're reference types, you can register them with the container. But like I was just saying about the structs, given that record types are mainly there for entities, you're more likely to use a factory pattern then you're not really likely to want to register them with the container. So like we talked about the factory pattern just now, I've written a blog post where I very specifically bring together all the stuff I've been talking about factories and focus it on C# records. Next, we have something that no one really talks about when using dependency injection in C#. We nearly always talk about classes and interfaces being registered with the container, but delegates are also a first-class citizen and can be registered as well, because under the hood, they have classes created in IL for you. Now, in theory, you can register the anonymous delegates from sort of like the func T family, where you've got func T1, func T2, func T3, etc., etc., etc. Problem with that is they're hard to distinguish from each other because they all share a very similar signature. So instead, what we do is we go really old school, way back to C#1 and start looking at custom delegates. Now, I go into the details on my blog because it sort of goes a bit in depth. But to give you a quick example, I really hate system date time now as a static property. Really hate it. Now, I know Adam's got a blog post where he talks about having an interface and a class to abstract away from the system implementation so that you can mock it. But what we can do is, instead of going through the ceremony of going and creating an interface and going and create a class, we could go and create a delegate function. So in this situation, I've got a delegate function called get current UTC date time. Doesn't take any parameters, but it returns a date time. And then in my services, I go and add a singleton, which is that delegate type. And inside, I just have an anonymous function that returns date time UTC now. So it's taken away all the ceremony of having an interface and a class to get the date time. The delegate, you can still mock that in your unit test, because at the end of the day, it's just a function signature. So you could either use sort of end substitute or mock to mock that, or just, to be honest, if it's something very simple, just do a concrete function within your unit test that says, for date time, give me back 16th of February 2021. Makes things a lot simpler. I've skipped ahead of where I wanted to be. So you may have noticed that I registered the delegate as a singleton and may be thinking that the date time returned will be captured the first time it's called, because we're sort of saying, go and get that date time. Is that going to be captured? But that's not the case, because what we're capturing is the delegate, the function signature, not the result of calling the delegate. So it's the same principle that we talked about in the middleware pipeline that I covered earlier, where what you're doing is you're registering a signature and an implementation, but not actually calling that implementation. So in this, again, another very contrived example, I consume the delegate in the controller constructor and cache it in a field. I then invoke it at the time of the constructor is run and cache that result in a field. In the get action, I then force a 3-second delay. I then call the delegate again and return a string with both values. Now, as you can see here, the result shows that even though the delegate is a singleton, the result is not generated until invoked, the first time in the constructor and the second time in the get method. And hence why when we get the result, we've got our 3-second difference. A feature that's supported by other containers, such as Autofac, is being able to specify a dependency to be resolved by the container using a string name or key. Now, it's considered a little bit of an anti-pattern, as it comes back to the idea that your application code shouldn't really know about the container's mechanics. But what if you could do that without your class having any knowledge of the container and not having to go off and use some other container like Autofac? So this occurred to me a while ago when I had a situation where I had a type of mapping algorithm that was determined by what thing came out of the database. So this was what we were talking about earlier during the questions of effectively, it's an abstract factory, that we want something to decide on this condition, I will give you this type of instance. But what we want to do is try and abstract that up into the container so the calling class is totally unaware of it. So it's a bit long-winded to try and describe it here. So there's a link to the blog where I've gone into, I think it's a 2 or 3-parter, I can't remember, but it goes into a lot of detail. But I do have an example here that's quite aligned to what we were talking about in the chat. So I've got this interface, I Kelvin mapper, that's got this function 2 kelvins based on a decimal value. I've got implementations, centigrade to Kelvin, Fahrenheit to Kelvin, Rankine, Kelvin to Kelvin. We then register all those with the container using their actual types. Now, following on from what I was saying about using delegates, we also have the delegate declared here that takes a string and returns the required implementation of the iKelvin mapper interface. Now, in the code here, I've used a simple switch statement based on a character value. But I could have done something more advanced, like using a dictionary or possibly custom attributes with a bit of reflection. There's various ways you could attack it, depending on how many scenarios you've got and how complex the code needs to be to go and instantiate these things. Whichever way you chose to do it, the delegate is the secret sauce, as it allows us to lift the logic out of the consumer and up into the container. And we don't have to have some kind of abstract factory class. We can do it all within this container registration. So the consumer will use the delegate to pass the string key and get back the correct mapper instance that it needs. So as I say, effectively, we've got an abstract factory. So now we've got our consumer, which is a class get temperatures. It takes in our Kelvin converter mapper, which is our delegate. And then all it has to do is it's got a method where it takes in a scale and a decimal value. It goes to our mapper, passes in the scale, which will be our K, F, C, etc., and calls that will go and get the instance, can call the 2 kelvins, passing in our decimal value. So that replicates our function signature. And that way, our consuming class has no knowledge about the container. It hasn't got it. All it needs to know is I pass in some string character. It will give me back the right mapper that I can then go and call. The decorator is another gang of 4 pattern that can be used to extend the functionality of a class. And it does it by wrapping it and then re-implementing all the members. But where necessary, intercepting the incoming parameters and outgoing result to do something else. So the most common example you probably see of this in .NET Core is where you want to intercept a call to something by putting a logger in the way and say, I want to log the parameters coming in, and I want to log the results going back out. To do this, we still need the original class to be injected into the decorating class along with other dependencies, which in our case is the logger. In the example code here, we have a class called doSomething that implements the iDoSomething interface. First, we register the class as a concrete type and not through the interface. We then have a decorating class called logging doSomething that takes the original logging class and it requests the registered original logging class in its constructor. It then goes and re-implements getHelloMessage method, this time with the code that intercepts the input and output of doSomething's version and then writes it out to the log. We then go back and register the new logging doSomething against the iDoSomething interface, which is then used by the consumers. The last feature missing from the Microsoft container that is supported by others is registration of services by convention or assembly scanning. Now, personally, I'm not a big fan of doing this because I'm a complete control freak and I want to know exactly what's going on with my registrations, because I've been bitten too many times by things getting registered with wrong lifetimes or wrong implementations. However, if you've got masses and masses of classes that you need to register within a particular assembly, I get it. That's really laborious and painful, and you may be looking for a way to short circuit that pain. Several offerings out there, but probably the most well-known is Scruta, where you define a set of rules for criteria for registering classes and interfaces. Now, there's one nice thing I do like about Scruta, which is nothing to do about this automatic registration, it's got a very nice fluent syntax for doing decorating of classes, where you can say, I've got this class and decorate it with this other class. A lot simpler than our hand-cranked version. So one last topic I want to give a brief mention to is about performance. Now, some of your registered classes may take a while to be instantiated, which will hit you when an object is created the first time and may impact on your users. If this is the case, you may want to consider having some sort of background hosted service that starts up with the application and requests all the registered services from the container. This potentially has two benefits. Namely, singletons will get instantiated before your first call comes in. So they're there and ready to go. Your first call doesn't take the hit of going and creating that instance for the first time. But the second is that transient and scoped instances, whilst it'll go and create them and then throw them away, there's a side benefit if it's gone through the JIT compilation process. So whilst there's not a direct performance boon by having those instances ready, it's gone through the JIT, and therefore it'll go and create new instances a little bit faster. Now, Andrew Locke's got a really good blog post on this, so I'm not going to repeat everything here. So I highly recommend going and looking at that if you have got some singletons or some objects that are very slow during their constructors. And that just about wraps it up from me. Thank you for coming to the talk. Hope I've provided some value, even if it's only one or two sort of golden nuggets hidden away inside .NET Core. If you want to hear any more of my ramblings, I'm on Twitter quite a bit at Steve Talks Code. I do have a blog where I've written mainly about dependency injection and configuration. But before I go, a few honourable mentions. Andrew Locke has a brilliant blog that covers all sorts of .NET Core related things. He's got his ASP.NET Core in Action book, and I don't know where he is with the version 2nd edition. I think it's still a MEEP, it hasn't been published yet. That's on Manning. The Microsoft Docs page is well worth a look, especially if you're migrating from, say, Core 2 to Core 3 or .NET 5, because there are those subtle changes that I discussed at the start of the talk. Last but no means least, there's Mark Siemens' blog and the book he co-wrote with Stephen Van Dusen, I think it is. There is an earlier version, but this version covers a whole host of all the different DI containers and how they differ from each other, and compare them to the Microsoft conforming container implementation. Now, Mark's not a big fan of the Microsoft implementation, but read the book and make your own judgments. And with that all said, that's the end of my talk. And thank you for coming along, and I'm happy to take any more questions.